Welcome, Honors Geometry, to our second video of the year, our second video of this unit where we are looking back at topics that were missed when we left last year in Algebra 1. So what we're going to get into today is we are going to get past our polynomials and we're going to talk about factoring. Factoring is a big topic. You're going to see it here in the remainder of geometry, but a big thing is when you get into Algebra 2, you're going to see it there. And it's a skill that your Algebra 2 teacher will expect you to have some remembrance of. So we're going to build throughout this year to continue to use factoring. So when you get into Algebra 2, you're prepared. So really the first question becomes, what is factoring? Okay, it's probably something maybe you've heard of before, maybe you haven't. Okay, but let's talk about what factoring is going to mean for us. So when we talk about factoring, we talk about how we're going to separate a polynomial back into a product. And now, you may be looking at that and be like, not sure what that means. So let's look back here real quick at our polynomial notes. So last time when we got together, we were looking at polynomials. And here at the bottom, we were looking at foiling. Okay, we had a binomial times a binomial, or we had some binomial times some trinomials. How factoring is going to work is we're going to be given these final answers that we got on these FOIL problems, and we're going to be asked, how do we take it back into what we started with? So how do I take this 18x squared minus 27x minus 5 back into the product of these two binomials? And that's what our whole goal is when we spend this time in factoring. Now, since we know kind of what our goal is, let's write down some of those examples. Okay, we're going to get to final answers where it's maybe a binomial times a binomial. So maybe it's 3x minus 4 and x plus 5. Okay, that's one example of what it may look like. Okay, there's other ones that we could write out, or it could simply be one like this. Okay, up on the top of our polynomials, when I had this out, I could have mentioned this. This is also a factoring problem. You're given a polynomial and you wrote it as a product. Even though it's not a binomial times a binomial, this is still a product. It's something times something. Okay, even if there's just a number or a variable or a coefficient and a variable or a number and variable out front, that's still a factor problem. So I could have 4 times x plus 7. Okay, there's some examples. So now, when we get into factoring, we talk about how there is a process. Okay, in every factoring problem, no matter what we look at, we'll all start with the same first step, which is to check for a GCF. And you're going to notice up at the top, if I brought this out, we're factoring with a GCF. That's our main topic here for today. So now, we know what our first step is. Let's talk about what GCF is. So first off, GCF is an acronym. It stands for greatest common factor. Now, some of you may be looking and saying, I'm not sure what that means. So if we break it down into maybe some easier or simpler terms, greatest really is just a big name for saying it's the biggest. Okay, common is something that is shared between them. And now, factors where it gets interesting. Okay, when we talk about factors, those are numbers that we multiply together to give us that number that we are writing the factors of. Okay, and when we get down here to example 1, when we're writing down the factors of these A, B, C, and D, it'll probably make a lot more sense. So it will. So now, what is a GCF? And we kind of wrote it out here up on top, talking and breaking down what greatest, what common, what factor is. And let's write out something down here as well. Okay, so when we look at what a GCF is, it's the biggest or largest number or variable that can be divided out of every term. Basically, I'm writing down a bigger definition from what we have up here. Okay, biggest, and large. Number of variable that can be divided out of every term is something that's shared, and a number that can be multiplied. Okay, that's just a fancy way, but really what we need to think about, it's the biggest shared numbers that multiply to give you that number. So now, you probably talked about earlier in your education about factors of numbers. Okay, what we're going to do is we're going to find the greatest common factor of these numbers, and again, it may be something that you've already done. So the easiest way that I'm going to do these is I'm going to start to write out the factors of every number. So you may be looking saying, well, how do I know what the factors are? Okay, one may look and say, well, you have to know your multiplication tables. Okay, well, sure, we know those, but there's also a shortcut, and let's look at the shortcut here. Okay, the shortcut, some may look and say it's not really a shortcut, but really it's more just a way to guarantee that you get all the factors. What I'm going to do is I'm going to start underneath this 12 and write 1, 2, 3, 4, 5, 6, and I'll stop there. What I'm going to do, how I check to make sure like 1, 2, 3, 4, 5, and 6 are factors, is I'm going to take my calculator, I'm going to divide that big number up there, which we have by 12, and I'm going to start dividing it by this first number 1. When you divide it by the numbers that you have listed out there, if your answer is a non-decimal, that means the number that you divided by and the number you get in the calculator are factors. So 1 and 12 are factors because I divided by 1 and I got a non-decimal answer. So 1 and 12 is a factor of 12. Okay, I go back here. 12 divided by 2. Okay, look, I get out a non-decimal answer. That means the 2 that I divided by and the answer I got of 6 are a factor of 12. 12 divided by 3. Ooh, I get, again, a non-decimal answer. So 4 is a factor, 3 and 4. What I divided by, what I got. Okay, 12 divided by 4. Ooh, I get out an answer of 3. Now, notice above this, I had 3 and 4. 4 and 3 is just the same numbers in different orders. That is what we call a repeat. That would tell you right then and there, you have listed out all the factors and you're done with listing out the factors of 12. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Okay, so now I'm going to go back here to my notes. I'm going to write that down under my 12. 1 and 12, 2 and 6, 3 and 4. Okay, you got to do the same thing for 48. It's a larger number. So again, the larger you get, the more you may want to do this trick. So I'm going to put 48 up here beside the 12. And now, Again, I'm going to just start writing down some numbers. I'll just put 6 there. I can put more, I can put less. Okay, so now I start here in my calculator, and I'm going to look and say 48 divided by 1 gives me 48. It's a non-decimal answer, so I know 1 and 48 have to be factors. 48 divided by 2, again, a non-decimal, so 2 and what it gives me out of the answer of 24 is a factor. 48 divided by 3, again, a non-decimal answer of 16. 3 and 16 must be a factor. 48 divided by 4, I get out an answer of 12. 4 and 12 must be a factor. 48 divided by 5, I get a decimal answer. That means 5 and nothing are a factor of 48. If you get out a decimal by dividing by that number, you cross it out. 48 divided by 6 gives me 8, a non-decimal, so I write it out. I've had no repeats yet like I did here on 12. I need to continue with the numbers 7, 8, 9, 10. Let's go up to 10. Okay, 48 divided by 7 gives me out a decimal answer, so I have to cross it out. 48 divided by 8 gives me an answer of 6. Notice 6 and 8, 8 and 6, they're the same thing. Cross out the one that repeated and everything below it. Now you have written out all your factors. So I could go here and I could look and say 48 has 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. So now, once you have written all your factors, your greatest common factor will be the number, or the largest, number that they both share. Okay, now, this 12 has 1, 12, 2, 6, 3, 4. Okay, notice both of them have that large number of 12, and that's the largest under both of them. That makes that my GCF for these two numbers would be 12. Okay, now we can do the same thing that we just did on B. What I'm going to advise you to do, stop for a second, do the same thing that I just did with listing out the numbers if you have to for 12 and 48. Check and see what did you get for the GCFs of these. Because when you come back and you've paused and tried it, we're going to go through them and give you the answers to make sure that you agree. Okay, so you should have came back. You should have found that on this one, looking at your GCFs, 13 is what we call a prime number, meaning that the only two numbers that are factors and that multiply to give you 13 are 1 in itself. For 44, we had 1 and 44, 2 and 22, 4 and 11. So now, this one's interesting. The largest number that they both share is a 1. When you look and say the largest number that they both share is a 1, this actually is telling us that there is no GCF. If the only number that they both share is 1, there is no greatest common factor between those two numbers. Our big thing is when we check for GCF, we're looking for really a number other than 1. Okay, and why that is because when we divide by 1, we'd still get those same numbers again. So now, we've done 2 numbers, now we're going to get into 3. So, let's walk through the 3. We have a 6, an 18, and a 40. So now, you're going to do it the same way that you would if there was 2 numbers. Factors of 6. We have 1 and 6, we have 2 and 3, and now 3 and 2 would be my first repeat. So that's where I'd have to cross off and stop. Okay, if I go to 18, I have 1 and 18, 2 and 9, I have 3 and 6, 4 gives me out a decimal, 5 gives me out a decimal, I have 6 and 3. 3 and 6 and 6 and 3 are repeats, or the same number, so I'd have to cross it off. There would be my factors. Okay, and then if I go to 40, I would have 1 and 40. I'd have 2 and 20. 3 is a decimal. I have 4 and 10. I have 5 and 8. 6 gives me out a decimal. 7 gives me out a decimal. And for 8, I have 8 and 5. 8 and 5 and 5 and 8, that's a repeat. So I have everything listed. So now, if I go and write them on my paper here, so I see them on my notes. Okay, I have 1 and 6, 2 and 3. Okay, I have 18. I forgot to do that for 6, but it's fine. I have 1 and 18. I have 2 and 9. I have 3 and 6. And then for 40, I have 1 and 40, 2 and 20, 4 and 10, 5 and 8. So now, when looking for the GCF, or the greatest common factor between three numbers, all you're looking for is what is the biggest number that all three of them share. So like here, for 6, my biggest number under 6 is 6 itself. 18 shares 6, but 40 does not. So 6 cannot be the GCF. Next biggest number under 6 is 3. Again, 18 has 3, but 40 does not, so that does not work. Okay, 6 has a 2. 18 has a 2, and 40 has a 2. 2 is actually the largest number that all three of them share. That means that for this problem, the GCF is 2. Okay, now, just like we did on that second example, stop, pause this video real quick. Okay, try and see if you can list out all the factors of 4, 24, and now 90 is a bigger number, and see if you can get the GCF that we're going to get. Okay, once you come back, we're going to work through the problem together. Looking for which number and the biggest number do all three of these have in common. And now, just like the last problem, all of them have a 2, and that's the biggest number that they all share. So this one, just like C, the GCF, is going to be 2. Okay, and that again may be a little bit of a refresher. You may have done GCF in your previous classes, maybe not in Algebra 1, but earlier in your math. So now, what we're moving into is GCF between variables. This is an interesting one, because to find a GCF of a variable, there's a couple things that you have to look for to determine. Okay, so to determine a GCF with a variable, every term has to have that variable. Okay, and you're going to notice our commas separate our different terms on these problems. So I'm going to just draw lines where the commas are to separate into the different terms. Okay, so you're going to first ask yourself, which variable, and it may be none, which variable does every term have? And then how you know what to do with the exponent is it's the lowest exponent on that shared variable. So if you think everything has an x on it, you're going to look and say, which is the lowest exponent on x? So if we look here at A, my two terms are x and x squared. Both of them have an x, so I know my GCF has to include an x. Now I'm going to ask myself and say, what is the lowest exponent on that x out of the terms? And the lowest exponent is from this first one. Remember, if it doesn't have an exponent, it really has an exponent of 1. So this x is really x to the power of 1. Okay, so x to the power of 1, which is just x by itself, has to be my GCF there on A. Okay, here on B, I see my two terms. Okay, I look and I say they do not have a shared variable in common. One of them has a y, one of them has an x. That makes it on this one that there's no GCF. If they don't have a shared variable, they don't have anything in common. Okay, here on C and D, these are 3 terms. Okay, you're looking for, on these 3 terms, do they have any variables or letters in common? And here on C, all of them have an x. So I know that it's going to have to do something with x. Now, once you identified what the shared variables are, ask yourself, what is the lowest exponent on that shared variable? My lowest exponent on any of the x's listed above is 2. So x squared, or x to that power of 2, is going to be my GCF. Okay, looking here at D. Okay, in these 3 terms, notice this is an interesting one because they all have an x in them, but they also have a y in it. So there's actually 2 variables that are a GCF in this problem. That is fine. Sometimes you will have 2 variables, sometimes you have 1, sometimes you have none, sometimes you have more. So now, starting with the x, since they all share an x, ask yourself, what is the lowest exponent you see on any of the x's? On the x's up above, I see a 4, a 2, and a 3. 2 is the smallest number out of that, so 2 becomes then my GCF, x squared. Okay, then I look at y. On y's, I have a 2. If there's nothing there, there's really a 1 and a 2. 1 is my lowest one, which I can put the 1 there for right now, but your final answer should always have it by itself. X squared y. Anything to the power of 1, you just don't put any exponent there. Okay, why we did this step for 1 and 2 is because when we get into our factoring out of the GCFs, we're going to actually combine 1 and 2 to give us how we actually go throughout these problems. So let's go back here to the back and combine them to factor out GCFs. So now, we're getting into the factoring part. This is where we need to write it as a product, so we're going to talk about that. So first, here on A, when we get to it, the first thing that we have to think about is our GCF. We need to be thinking about it in the sense of numbers and of variables. So we're going to combine the first part and the second part that we did. So our numbers are going to come from what numbers or coefficients we see in this problem. So in here on part A, the numbers or coefficients I see in this problem are 3 and 12. I'm going to ask myself, is there a GCF between the numbers 3 and 12? And actually the answer is yes. Okay, so if I go up here, I have some space here right now. Factors of 3 are 1 and 3. Factors of 12, 1 and 12, 2 and 6, 3 and 4. Notice how both of them share a 3. Okay, so back to this problem. If I look at why it has a GCF, the factors of 3 are 1 and 3. For 12, it's 1, 12, 2, 6, 3, 4. Okay, notice out of those numbers, the numbers that they share in common, they both have a 3. That means my GCF so far is going to have a 3. Now, I also need to think about the variables. The terms going back to, remember, our polynomials, terms are separated by a plus or minus. In this problem, there's 2 terms. There's a 3x and there's a 12. Okay, for you to have a variable as a GCF, you're looking for, do those terms have a letter in common? Do they both share a letter? And the answer is no. One of them has an X, one of them does not. So for a GCF for a variable, there is none. So my only GCF is 3. How we factor with this GCF is you put that GCF right out in front. After your GCF, we're going to have these parentheses, so we are. And inside the parentheses is going to be what we get when we divide each term by that GCF. Okay, so really it's going to look out something if I write it out step by step. We're going to take 3x, which was the first term, divide it by that 3. Then we're going to take plus, take that second term, divide it by that GCF of 3. Your final answer is what you're going to get when you simplify that. So 3 stays there. 3x divided by 3, the 3's would cross out and leave me with just an x. Plus, okay, 12 divided by 3 in your calculator gives you an answer 4. This right here, 3 times x plus 4 is your final answer. Your GCF should always be outside of the parentheses. Okay, and inside your parentheses, you should always have the same number of terms your beginning problem did. Okay, our beginning problem had 2 terms, 3x and 12. Notice, inside our answers, the final one has 2 terms as well. Okay, let's go here to B. So, it's the same process. The more you do these GCFs, the quicker that you get to visualize what the GCF is and what you would get when you get to your final answer. So, if I think about the GCF, we're going to think about it in 2 different things. We have our numbers, we have our variables. Okay, the numbers that I see in this problem are the numbers in front of x, which are 4 and 5. It doesn't matter about that minus. Okay, I'm going to ignore the signs right now and just write the numbers. First off, 4 and 5 have no GCF. That's because, remember, the factors of 4 are 1, 4, 2, and 2. Factors of 5 are 1 and 5. The only number that they share in common is 1. And remember, in the front, when we were looking at 13 and 44, if you say the answer is 1, they have no GCF. Okay, now, looking at the variables, is there a letter that both terms have? And the answer is yes. They both have an X. So now what we're going to do is we're going to ask ourselves, what is the lowest exponent that you see on those X's? Well, this X has an exponent of 3. This exponent doesn't have 1, but remember, it's really an exponent of 1. 1 is the lowest exponent I see, so 1 would go there, which I can put the 1, or I can look and say just put X by itself. X becomes our GCF for this problem. Sometimes your GCFs will be numbers, sometimes they will be variables, sometimes they will be both. So I'm going to put an X here. Now, remember, your final answer is if you take your 4x to the power 3, divide it by x, minus 5x divided by x. You're dividing your original problem by that GCF. So I get left with x times 4 stays there. X to the 3 divided by x. When you divide, you subtract exponents, or it's like you're taking away. You have 3 x's and you're taking away 1. That leaves you with 2, so it's x squared. Minus 5 stays there because there's nothing with numbers. You have 1x and you're taking away that x, so there's no x's there. So it just gets 4x squared minus 5 in the parentheses. that would be then your final answer. Okay, so now, here on the next problem, let's look at this. So, if we look at our GCF, okay, and again, if we look at it in both branches, we have numbers, we have variables. Ignore any of the signs for right now. We're going to talk about the sign here in a second. Your numbers that you see are 3 and 9. A GCF of 3 and 9 actually is 3. 1 and 3, 1, 9, 3, and 3. They both have a 3 there in common. Okay, if we look at variables, both of these have an X, and really our GCF is going to be X, and it's going to be the lowest exponent that you see on any of those X's. This one has a 4, this one has a 3. Lowest exponent I see is 3. So, I have a GCF both for numbers and variables. All as that means is when we go out here, we're going to put both of those outside of the front parentheses. Now, like I said, we'll talk here in a second about the sign. Okay, whatever has your highest exponent of your variable, you want to make sure that that sign is always positive when you end out with your answer. In this problem, my highest exponent is negative to begin with. If that happens that your highest exponent is negative right at the beginning, you want to take out a -1 or a negative with your GCF. Okay, you always want your leading term with your highest coefficient on the variable to be a positive number. So I'm actually going to take out a -3x cubed. So now my step then would be to take what they had at the front, divide by what I said was the GCF. Divide by what I said was the GCF. So now my final answer, -3x cubed. Okay, if I go through this, -3 divided by -3 is a +1. I have 4 x's and I want to take away 3, so I'm left with 1x. Okay, +9 divided by -3 is a -3. I have 3 x's, I'm taking away 3, so I have none left. Now, you could write your answer like this, or you could have -3x to the power of 3x minus 3. If you don't want to have that 1 there, you can just write it as x minus 3. Okay, these GCF problems get easier as you practice and work with them. Okay, so now, if I look here at D, the numbers that I see on D are 12, 3, and 6. Okay, if I'm writing out my GCF, okay, if I have to, you can always take a separate piece of paper and figure out your GCFs there. The numbers that I see were 12, 3, and 6. 12 is 1 and 12, 2 and 6, 3 and 4. 3 is 1 and 3. 6 is 1 and 6, 2 and 3. The biggest number that all 3 of them share is a 3. So my GCF is going to include a 3. And now, if I look at each one of these terms, 12x to the 4th is a term. 3x squared is a term. 6x. I'm ignoring the plus or minus. Notice, they all have an x in it. And the highest exponent that I see is actually down here at the 6x, which is a 1. So that means x to the power of 1, or x by itself, is going to be included in my GCF. Now, since my biggest exponent of x has a positive, or really nothing in front, I don't have to take out a negative. You only take out a negative when your highest exponent with your variable has a negative in front of it. So now, taking out 3x. Okay, it's like what I'm going to do. 12x to the power of 4th. I divide that by what I said my GCF or 3x was. Plus 3x squared divided by what I said my GCF was. Minus 6x divided by what I said my GCF was. Your final answer should always have your GCF in front and what you get when you divide that GCF out. So 12 divided by 3 is 4. You had 4 x's, you took away 1, so you have 3 left. 3 divided by 3 is 1. Now, I can either write the 1 or I don't have to. Okay, I'm going to write the 1 for right now, then I'll rewrite it. You had 2 x's, you took away 1, so you have 1 left. Minus 6 divided by 3 is 2. You had 1 x, you took away, so you have no x's left. That could be one way you write the answer, or you could write it 3x times 4x to the power of 3 plus x minus 2. Okay, both of those work as answers. Okay, let's go down here to E. Okay, here on E, if you have to, okay, get another sheet of paper if there's not enough steps, or if you want to figure out the GCF like we did on the last problem. Okay, my numbers are 2, 4, and 6. Okay, 2. Factors of 2 are 1 and 2. 4 is 1 and 4, 2 and 2. 6 is 1 and 6, 2 and 3. The biggest number all three of them share are 2. So my GCF includes a 2. Now, looking at the variables, my variables are 2x, or my terms, 2x cubed, 4x squared, and 6. Okay, I'm going to ask myself, do all three of those terms have a variable that they share in common? And the answer is no. Okay, they all don't have an x with it, so the only GCF I have in this case is a number. So I'm going to take 2, and now, since my biggest exponent is a positive in front, I don't need to make this a negative. You only make your GCF be a negative when your highest exponent, okay, that coefficient or the number in front with your highest exponent is negative. So I'm going to take 2x to the power of 3 divided by 2. Minus 4x squared, divide that by 2. Plus 6 divided by 2. So now I get a final answer of 2 times. 2 divided by 2 is 1. I'm not going to write the 1 this time. I had x cubed. I didn't take away any, so I'm just left with the x cubed. Okay, negative 4 divided by 2 is a negative 2. X squared, I didn't take away any, so it stays x squared. Plus 6 divided by 2 is 3. There would be my final answer. Okay, now, looking here at F. Okay, if we go through it like we've been seeing the last couple, 5, 10, and 2. Okay, factors of 2 are 1 and 2. Factors of 10, 1 and 10, 2 and 5. Factors of 5 are 1 and 5. The only number that all three of them share is a 1. That means no GCF for numbers. Remember, a GCF of 1 means no. Now, if I write out my terms, ignore the pluses and minuses. I have 5x cubed. I have 10x squared, and I have a 2. Okay, there are my terms. I'm going to ask myself, do they have a variable in common on all three of them? No. Since there is not a variable or a letter common on all three of those, they do not have a GCF with a variable. Now, so we may be looking saying this one has no GCF, but this one has the rule that we're talking about. My highest exponent with my x has a negative in front of it. If you have your leading term be a negative, take out a negative 1. Okay, you're taking out a negative, you're really taking out a negative 1. When taking out a -1 or dividing out a -1, all as it does is it changes the sign of everything in your original problem. So instead of this being a -5x cubed, it's a positive 5x cubed. It's now also a positive 10x squared because it was negative to begin with. And then it's a -2 because you switch the sign. Okay, and that's all we can factor on that one. Okay, getting here to G. My numbers are 15 and 10. 15, I have 1 and 15, 3 and 5. For 10, I have 1 and 10, 2 and 5. Notice they both share a 5. So that means my GCF is going to have something with a 5. Now, my terms are 15x squared y squared and 10x y squared. Looking for variables. Notice both of them have an x. And the lowest exponent that I see with the x is actually right here. It's an exponent of 1. It's by itself. So I'm going to just let this be by itself. Now, they also both have a y. The lowest exponent that I see with my y is a 2. So, I say y to the power of 2, or y squared, is my lowest, or my greatest common factor in this case. So now, to get my final answer, I'm going to take that GCF, and it's like I'm taking every term and dividing by it. Okay, so I wrote it out, I divided it. Now, getting your final answer. You're left with the 5xy squared. 15 divided by 5 is 3. And then I look and say, I had 2 x's, I took away 1, so I still have an x. I had 2 y's, I took away 2, I don't have any y's. Plus, 10 divided by 5 is 2. I had 1 x, I took it away. I had 2 y's, I took it away. And there would be then my final answer. Okay, now looking here at the last one on these notes. Okay, my numbers are -3, 6, and 2. Okay, now the only number that they share in common is a 1. But now, look here. Leading term is negative. So I know I have to take out a -1. If your leading term when factoring is negative, take out a -1 with your GCF. So now, these terms. Okay, if I get my piece of paper here again, okay, and if we work at this one, we have a 3x to the 5th y to the cubed. We have a 6x to the 4th y squared. And we have a 2x to the cubed y. Okay, here are my terms, and let's get here. There are my terms. So now, every one of those terms has an x, and the lowest exponent I see with the x, I have a 5, a 4, and a 3. 3 is the lowest, so that becomes part of my GCF. When I go here to my y's, I have a 3, a 2, and remember, if there's nothing, there is a 1. 1 is the lowest, so I take out a 1, or just y by itself. So, my GCF, because I need to get rid of that negative in the front, is really going to be -1 times x cubed y. So now, to work out this problem, I'm going to think about taking and writing that GCF. The GCF always has to go in front of your parentheses. I'm going to then take every term inside and divide it by what we said the GCF was. Okay, so I divided that all. Now, what I get out once I divide is my final answer. So GCF always goes in front. So now I look and I say, -3 divided by a -1 is a +3. You have 5 x's, you're taking away 3, so you're left with 2. You have 3 y's, you took away 1, so you're left with 2. 6 divided by a -1 is a -6. You had 4 x's, you took away 3, so you're left with 1. You had 2 y's, you took away 1, you're left with 1. 2 divided by a -1 is a -2. You had 3 x's, you took away 3, so you're left with none, so I don't write anything. Had a y, took away a y, have none, so I don't write anything. There is my final answer. And there would be your factoring out of your GCF. Like I said, these factoring out of the GCF problems get easier the more you work with them, okay? So the more that you go through and you practice these, the more that it will get easier to work with. So it will. So now that we're done here with our GCF, you're going to practice, and then we'll continue on with factoring next class. See you next time, Honors Geometry.